In this video, I actually want to talk about what do scientists actually do with inconsistent data. It's something that we actually struggle with on a regular basis, and it is a real difficulty. So if you don't know me, I'm Professor Dave Maslock. I'm Associate Professor of Innovation Strategy and Entrepreneurship, and I created this whole reciprocity project to give back as much as I possibly can. There were so many people that helped me out that I wanted to pay the favor for to help you out. So research rarely works when you're doing it properly and you're doing everything that you should be doing. It really is difficult to get a insight in which the results you get are entirely consistent. It really just doesn't work out that way because the world is complicated. There's lots of things that go on in the world that are hard to explain and that they complicate what research should be. We can create sort of simulated models and what it should look like, but then when we go into the real world, we see a lot of different things that don't really look like the way that we thought they were. And so really we have to deal with a lot of inconsistent data on a regular basis. So anybody that's actually dealt with real data and they've actually analyzed real data, they will figure out that, oh my God, it is messy. It is really difficult. And so we don't have, a lot of times we make, when we have a hypothesis and we get that information back and we study it and maybe we're doing something with hypothesis testing, and what we're going to look for is a p-value that's greater than 0.05. I know that there's lots of contention about p-values, but let's say you don't get that p-value 0.05, then we would say that it's not, our hypothesis is not necessarily supported with that particular p-value. I'm not going to explain all of the ins and outs with that, but basically it suggests that the results are not supported. And then we have to go back and try to figure out why the results are inconsistent in terms of what we thought they might be. And so if you're a scientist right now or a researcher right now, I'd highly suggest for you to think about that. And the first thing that I would do, this is what I try to do. It is hard to do because we have constraints in terms of how much we, how much we write and how much sort of detail we can put into every single scientific journal article. But this is what I try to do, is you try to be as transparent as you possibly can and really get into why it's actually inconsistent. So I think transparency is always the key. It's going to be the best thing for you. And to not get emotionally attached when there is inconsistent results and just say that there is inconsistent results. I know that's really hard to do because a lot of people get wedded to it, emotionally wedded to this sort of scientific stuff. I do, right? When you're analyzing things, and I'm just sort of speaking about my own true, how I feel about it. And I feel really wedded to the data and wedded to actually analyzing the stuff. And so it's really difficult to take that step back. But what I figured out is the way that you get around that sort of feeling wedded to it and being like, oh man, it doesn't work. It's just being transparent and just being like, that's the way it is. As soon as you get it. And then you don't get that sort of emotional response to it as much as you would think. So I would go back and try to think about why you might have this sort of inconsistency. And then you could even go so far as actually coming up with a post-hoc hypothesis about why that might have occurred. And obviously you have to sort of state that this is a post-hoc hypothesis and you're trying to explain why that there's this inconsistency or why something is not supported. But you really want to explain what is going on and why that is actually the case and think about why that is the case. Now, obviously, there's going to be, errors and input, data error input things, and you want to go through, make sure that you actually double check everything and everything is sort of doing what it should be doing. But, in terms of your analysis, but then, once you've sort of vetted it as much as you can, and then you're like, oh man, it's still not sort of quote unquote working in terms of what I thought it was going to be. Then you go back and you sort of postulate. You think about, why is this the case? Come up with some sort of explanation for why that is the case. And I think the biggest thing that you have to be is to your peer reviewers is to just be really upfront and consistent and transparent with your reviewers and everybody else in science and say that this is what's happened, and then you can actually create an appendix maybe it's some sort of online appendix in terms of explaining what's going to go on. Because sometimes what happens in the review process, if you didn't know this, is that the review process gets you to think about things. You'll end up sort of changing the some of the theoretical story behind the papers and stuff, just because the reviewers are in the editor trying to get you to cut to the chase to something that's really interesting. And so they're going to get you to sort of change things and sort of mold the theory around what they think is interesting and sort of come up with that. And so you have to go through and be transparent and be open with what you think is going on and create, often I just think of notes, making just notes, like as a scientist, like as a real scientist, making notes about what's going on. And then be okay. I think this is the most important thing, is be okay with the fact that you actually have inconsistent data. Doesn't mean that this is garbage or the thing that you're working on is bunk. If you've done a good job and everything, you've done all of your work, you can move on to something that is, you can move through your results. It doesn't mean that you have to have significant results all the time. You can have inconsistent results. And if you've done it rigorously and you've explained it, you can often get some really cool insights from doing that. So that's an important thing. It's just not being really, really like, oh my God, I'm really bad at this. I don't know what I'm doing. This doesn't work. No, don't have that. If you could just step back and just say, it wasn't supported. It wasn't, this is inconsistent, and just move on and then sort of speculate or think about why that might be the case. And that might turn into another paper after that. So with that, give me a thumbs up if you like this video, and do subscribe to the YouTube channel. Again, be transparent and don't feel emotionally attached to the fact that you don't have significant results in any sort of way or inconsistent results in any sort of way. Just move on and document what's going on, and then everything should be okay. You just have to document and tell the truth and, craft a story about what you're actually trying to do. You're a real scientist. All right. So anyways, take care and have a wonderful day. Bye.